Hello all, welcome to the next section, Advanced Observable Flows Explained. In this section we'll be unwrapping observables, passing values, combining items, and finally filtering the values. Let's begin with the first video of the section that deals with unwrapping observables. In this video we're going to see how to use .map and then learn about .flatMap in detail and it working. As we have already seen, there is often a need to create and consume nested observables. Let's say that the user ID is produced by an observable, and we have to use that ID to retrieve payments through another observable. Plugging everything into one seamless flow might not be so straightforward, and in cases like these, we've often used tools like .flatMap function. We'll first cover .flatMap function's close brother, .map function. It will later help us understand why it's necessary to use .flatMap function and how it is related to mapping. We'll first transform values with map. We've used .map function before as well. This is a functional method and it's really easy to understand what it does. It just transforms one item to another. Consider this example. It will go through each number and return a new value that is higher by 1. It's highly encouraged to never modify values in place in the .map function method, but to always return a new one. This is the code used to perform this example, so this approach will be bad. Instead of that, prefer the highlighted way. This approach helps to avoid concurrent modification bugs. It's easier to debug, and it's easier to reason about. Finally, .map function can be used to change the type of the value as shown here. Now, instead of date, a string type will be returned for the rest of the processing in the flow. To summarize, .map function takes an item and returns a new item to be processed downstream. The newly returned item can be anything of a different value, of a different type, or not changed at all. This can be represented in a figure like this. This map transforms apples to pears. We'll now see how all of this is related to .flatMap method. The .flatMap function is a map operation. It transforms one value to another. However, the way it does it is a bit different. Let's examine this with an example where we've used a bunch of IDs, and we need to request some remote service to receive data. This is our example code. Here we have 3 IDs, and each of them will initiate a new request using our mock HTTP request method. That implementation detail is not important here. Let's assume that it returns a working callable interface instance. For the sake of argument, we can set it to something like this. Let's see what will be printed in the logs. We'll run our app, and in our Android emulator we get this result. It's not really something we wanted to have. We got a bunch of observables because it was a function of the .map function to transform IDs to observables. Now take a look at these lines of code. The observable date type here is not something we want to work with. We were actually hoping for observable date. Now, there is very little we can do with them. The only way to get values from them is to do something like this when we run our app again. Now it will print the values we wanted to see. However, the way to do this is absolutely absurd. We need 2 levels of subscribe function. If we consider the previous conveyor comparison, the current setup will look like this. We can see here that we have an observable of observables, in which the actual items are carried. So, how do we fix that? The .flatMap function unwraps the unnecessary observable so that the flow becomes like this. It can be seen now that there is 1 level observables. So, if we replace the .map function with a call to .flatMap function, so it becomes this. We can just do a regular .subscribe function as we're used to. In the end, the .flatMap function is a transformation that expects the result to be of an observable type and unwraps the values of that new observable into the original observable that we're actually using, so it becomes much easier to consume. There are a few more .flatMap function variations that we can use. Recall this line that we used earlier. The .yql query call returns a single type and thus cannot be used directly with .flatMap function. which expects to consume the observable type. In this case, to work around that, we've added toObservable function to convert it to the observable type. However, there is a better way. Instead of using the .flatMap function, we can use the .flatMap single function to do the same thing. The .flatMap single function takes the single type and automatically converts it to the observable type. There are other similar methods like that. The .flatMap maybe function, used for maybe types, the .flatMap completable function, used for completable types, and the .flatMap observable function. This is used for observable types. We'll now look at .switchMap. SwitchMap function is a very close cousin of the .flatMap function. The difference between them is that the .flatMap function will return wait to return all the elements from the observable that were created inside .flatMap function, while the .switchMap function will only return elements from the newest observables that were created from the newest values. The easiest way to explain this is by example. First, let's take a look at how the .flatMap function will work with this block of code. This will basically produce two sets of items that will be numbered from 0 to 4. In total, there will be 10 items printed, because the first .interval function produces 2 items, limited by .take2, and each of these items will produce another 5 items, limited by .take5, and another .interval function inside the .flatMap function. So when we run the code, we'll get an output like this in our Android monitor log. Now let's try another version with .switchMap function. When we run this code, the output of this subscription will be a bit different like this. Here you can see that the emissions from the first .interval function that was produced inside the .switchMap function stopped immediately when the second .interval function was produced. That's what the .switchMap function does. As soon as the next observable is returned, it terminates the one that was used before it, and produces items only from the newest observable. This is useful, for example, in settings management. We might want to terminate the previous observable that was created with the old values as soon as the new parameters arrive. Alternatively, consider a case when we receive an item in an observable, and we start a network request. If the second item is received and the first request was started with .switchMap function, the first request will be cancelled before the second network request will be made. If the request was started with the .flatMap function, the observable will wait for the first request to complete before starting the second one. That's all in this video. Here we unwrapped observables using .flatMap.